Okay, in this video, we're going to look at something that's not explicitly on the spec, but I just want to make sure that you don't mix it up with what we've been talking about in these videos. So in the previous videos, we looked at the group of symmetries, okay, of regular shapes, which are sometimes referred to as dihedral groups. We're now going to look at something that's referred to specifically as the symmetric group. Okay, so it's denoted with the notation Sn. Okay, and it's the group of permutations of a set, and the order of this group is n factorial. So what we mean by this is if we considered S3, and let's say we drew out an equilateral triangle to visualize, okay, you could write 1, 2, 3. Now, the symmetric group is essentially every single way you could arrange the 1, the 2, and the 3. So in terms of figuring out how many ways we can do that, well, we've got 3 options for how many numbers we could put on this top vertex, because we could put 1, 2, or 3. Then once we made our first selection, for our next vertex, we've only got 2 options left, because we're going to use each number exactly once. And then for my final vertex, I've only got 1 option left. So to figure out how many permutations there are, you'd have to multiply these numbers together using the product rule for counting. So 3 times 2 times 1, which is equal to 3 factorial. Okay, and you can logically infer that if you were dealing with a square, it would instead be 4 factorial. However, in the case of the 3 numbers, we've ended up with 6 elements in total. Now that equals the number of elements in D3, our dihedral group, which you can see here. So actually, in the scenario where n is equal to 3, the dihedral group will give the exact same elements as the symmetric group, okay, and it would have the same group structure, okay, so essentially there'd be identical groups, okay, and in this scenario, when you have identical groups, you'd call them isomorphic to each other, so we'd say D3 is isomorphic to S3. Now this word, we'll look at this in more detail in an upcoming video. In terms of notation, we could write D3, and then this symbol here, S3, and that means isomorphic too. However, this only applies when n is 3. If we consider the square instead, okay, for the square, the order would be 4 factorial, which would be equal to 4 times 3 times 2 times 1, okay, which would be 24. So there'd be 24 elements in S4. However, you can see D4 written down here, and there are only 8 elements. Okay, so these groups would not be isomorphic, they would clearly be different because they have a different number of elements. And the reason this is the case is because n factorial will always be greater than 2n if n is greater than 3. That's something you can prove by induction.